Hello, everybody. Good evening, good afternoon, or good morning, whatever where you are. Warmly welcome to the second session of global climate change and its response from the perspective of carbon neutrality. My name is Yong Luo, a professor at the Department of Earth System Science, Tsinghua University. Tonight, I would like to take this opportunity to introduce a little bit about the facts and impact of climate change. Actually, it is the scientific basis for us to take the carbon neutrality action. So I do think it is essentially important for you to correctly understand the reason why we have to take the carbon neutrality actions. In my talk, you will have the opportunity to learn or to understand 4 parts. Say that what's the facts we already have observed in the climate system, and what are the natural and anthropogenic forcings or the contributions to the climate change we have already observed. And next, I would like to introduce how will the climate change in the near future. I'll see that the climate change projection, and I will emphasize how much space do we have to emission more carbon oxide and other greenhouse gases. See the emission space. And finally, I will introduce a little bit about the how does the climate change affect natural and human system. Before we move to the first part of my talk, I would like to start up with the introduction of some scientific concepts. The first pair are the weather and climate. You may or may not know, think about it before, but I do think it's quite important for us to distinguish what is weather and what is climate. You can find in the screen that weather refers to meteorological phenomenon occurring within a short period of time, say several seconds to several days. In particular, shorter than a month, 30 days, such as a thunderstorm, big wind, precipitation, or heat wave, or something like that. But climate is quite different. It refers to the average and statistically conditions of weather during a longer time, say months, seasonal, annual, several years, decades, and even longer. For example, hundreds of years, which is often represented by the average and normally over a period of time. Climate can reflect some basic meteorological features, something like cold, warm, dry, or wet, within a region or over the globe. In order to make you understand correctly the difference between weather and climate, now let's have a discussion. I would like to raise a couple of examples. The first example I want to raise is that, for example, on September 4th, 2015, it rained all day in Beijing. Yes, actually, you are right. It is absolutely weather, not climate, because this event occurred within 24 hours, a short period of time. The second example maybe is a little bit complicated. Say it rained all night in Beijing with the maximum rainfall amount since the year of 1951. In this case, is this still a weather event or climate? Yeah, somebody think it's a weather. Yes, it's belongs to weather because although it's very unusual because the precipitation amount is the maximum during the past 60 years, but it occurred in a short period of time within 24 hours overnight. So this phenomenon, this event belongs to weather, not climate, but it is very unusual. So we call it extreme weather event. Extreme. Extreme weather event refers to the rare event under reference statistically distribution in specified area. Generally speaking, the probability of the event, whether extreme weather event occurrence should equal to or less than 10%. So let's read another example. You can find that this is the variation, the time series of a certain meteorological variables, for example, the temperature or precipitation, whatever. But we can reorder this time scale from the minimum to the maximum, right? So what is the extreme? It's the leftmost end and the rightmost end. This is we call it extreme event. See that the leftmost end and the rightmost end. Usually you can heard some news from the media that for example, the strong precipitation in July 20 this year in Zhengzhou city, it is quite unusual. It is 1,000-year occurrence. So this is the return period or the recurrence rate. So it's very unusual. For example, the 50 years recurrence period or 100-year return period. We can use this term to illustrate that it's very extreme. So another case, the winter of 2006 or 2007 is the warmest since 1951. So let's think about if this event belongs to weather and climate. When we talk about the winter means December, January, and February. So the temperature averaged over 3 months. So in this case, it should belong to climate. And also because it is the warmest winter since the past 60 years. So it is a kind of extreme climate event. So I hope that after the discussion of these three cases, examples, you can distinguish clearly between the weather and climate. Then let's go to the climate change definition. Climate change refers to the variation of state of the climate system in decades or hundreds of years, or even longer in the even longer spatially temporally scale, which can be identified by the statistically significant change of its mean value or by the change of its variability. So this is a scientific definition of climate change. So in this description, you can find clearly that when we think about climate change, it should occur over a longer period of time, at least several tens years, several decades, or even longer, for example, the hundreds of years. For example, the change since the industrial era. Yes, the climate change definition is quite different with the definition of weather and climate. The time series is quite different. And the rise and fall of the mean value manifests the variation of the climate mean state, and the increase of the climate variability indicates the augment of the state of the climate instability and can regularize the climatic anomaly, such as the change in average temperature, average precipitation amount, maximum temperature, minimum temperature, extreme weather events. This is all the within the definition of the climate change. In order to introduce more clearly the definition, I would like to show this picture. Actually, it's the conceptual model of the climate change. In this figure, you can find that is a normal distribution curve to illustrate some meteorological variable. For example, the temperature. The temperature in Beijing, something like that. So in this case, in the normal condition, you can find that the mean temperature occurred more frequently. But the cold event and hot event occurred more very rare. So this is the current or the past climate state of climate. If due to some reasons, for example, the change in the solar radiation or the change in emission of carbon dioxide, the climate has been changed. So in this case, you can find the curve, the normal distribution curve moves rightward towards the high temperature. So in this case, the climate is warming because the average temperature increased. So this is the most common, this is the first understand for us to know what is climate change. If the average of the variable moves significantly. But in reality, the temperature change not so easy. In the same time, it moves to the warm temperature, say move rightward. But in the same time, the normal distribution curve also changed. In this case, the average temperature occurrence becomes less than normal. But the cold event and also the hot events occurred more significantly. So when we think about the climate change, it includes not only the significant change in average temperature, average variable, but also include the change in the variability. So this is the quite correct for understanding of the definition of climate change. Another key point I want to emphasize in the definition of climate change is the climate system. Climate system, this is a very important theory raised in the end of last century. Climate system is a complex system, include 5 spheres: atmosphere, hydrosphere, cryosphere, lithosphere, and biosphere. So before the theory of climate system, we understand usually the climate change, the climate, temperature, and precipitation, and rainfall. But right now we understand the climate change in a climate system concept. So the climate system includes not only the atmosphere, not only the temperature and precipitation, but also include the significant change in other spheres. In the hydrosphere, for example, the significant rise of sea level, it's absolutely the indicator of climate warming. And also cryosphere, for example, the significant shrink of the sea ice extent, the snow cover extent, and lithosphere and biosphere. For example, we can observe when we first see migrating birds earlier than normal. So this is an example or indicator of climate warming. In all these 5 components, there exist complicated physical, chemical, and biological processes, and also interact with each other. So the climate system is quite complicated, as shown in this figure. You can find that the climate system is quite complicated. We have to think about the incoming solar radiation and outgoing long wave radiation, and also the distribution of the energy received at the surface and lower atmosphere. For example, the exchange of sensible heat, evaporation between the land and ocean with the atmosphere. Actually, it's quite complicated. So this is the current state-of-the-art understanding of climate change. See, the change of any one of the 5 spheres of the climate system should be regarded as climate change, not a temperature rise. Global warming is not only the rise of mean surface temperature, the increase of ocean, the upper layer heat content, the retreat of glaciers, and the sinking of permafrost, the active layer, the narrowing of snow and the sea ice extent, and the steep decline of biodiversity, etc. So all these significant phenomena belong to the definition of the climate change. So till now, I do think you may understand correctly the scientific concept of climate change. There are 2 key points. The first one is the climate system. The second one is a longer period of time. So I guess you can understand, because when we observe the forthcoming winter is another warm winter, is it a climate change? You know, the China Meteorological Administration predict the next winter will be continue to be a warm winter. So in this case, is it belongs to the definition of climate change? No. One warm winter does not belong to the definition of climate change. Only the change tendency, because in Beijing, we observed more and more warm winters. This is the climate change. One warm winter does not belong to the climate change. So it is quite critical. You should consider the time scale or the period of time. So at least several decades or even longer, hundreds of years. So this is very important for us to understand correctly the climate change. But another climate change definition I want to show is also quite important. You can see from the screen that this is the definition of climate change as the Article 1.2 of UNFCCC, which was launched in the year of 1992. See, climate change means a change of climate which is attributed directly or indirectly to human activity that alters the composition of the global atmosphere and which is in addition to natural climate variability observed over comparable time scales. So you can see that this definition of climate change is quite different with the one I just showed you, just introduced. So I call this definition is a political or diplomatic definition of climate change. The day after tomorrow, the COP26 will be held in UK. The convention of the party of the UNFCCC, the 26th session will be held in UK the day after tomorrow. So over there, the participants of the COP26 see the delegation of different countries, the politician and the diplomatic persons. What they talk about the climate change is this definition. It's a political or diplomatic definition. So it's quite different for what I, as a scientist, think about what is the climate change. See, that's a little bit complicated. So in the international climate change negotiation circumstances, they talk about climate change only include that part of climate change induced by the human or anthropogenic activities. For example, the emission of carbon dioxide and other greenhouse gases, emission of the aerosol, the air pollutants, and also the change in the land surface, land use, urbanization and deforestation, or something like that. That is the climate change talked about in the international negotiation cases, chance. So now the scientific definition. So this is a little bit difficult to understand. So because to the in the Paris Agreement, we have to limit the surface temperature rise limit to 2 degrees centigrade compared to the pre-industrial era. we have to strive to limit the temperature rise right before the 1.5 degrees centigrade. This is the greenhouse gases reduction and the carbon neutrality or the temperature rise control target in the Paris Agreement. So in that case, the climate change only include the climate change induced by human activities, not include the climate change induced by the natural forcings. For example, the change in the solar radiation, the volcano eruption, and also the robot parameters for the Earth to operate. In that case, we include all these climate change is the natural climate variability. So, after this, I would like to take several minutes to discuss or introduce the quite important scientific concept, weather, climate change, and scientific definition and political definition of climate change. And another important message I want to let you know that this is the Intergovernmental Panel on Climate Change, IPCC. This is the international scientific assessment organization under the UN concept. It is a very important organization. For example, they produce several scientific assessment reports frequently, which are very important in supporting the international climate change negotiation and also the climate change policy from the policymaker worldwide. So this IPCC is co-founded by two fathers. One is the WMO, the Weather Meteorological Organization, and UNEP in the year for 1988. Its mission is to write climate change scientific assessment reports. Till now, they have already launched 5 assessment reports in 1990, 1995, 2001, 2007, and 2013 and 14. And right now, the 6th assessment report is being prepared. Actually, in the past August, the Working Group 1 of IPCC's 6th assessment report has already launched, issued. You can find the front page of different IPCC's assessment reports. Actually, this organization, IPCC, and its scientific assessment report are quite important. For example, you can from this slide that the launch of each IPCC assessment report provided strong scientific support to the international negotiation. For example, the second assessment report supported the Kyoto Protocol in the year of 1995. For example, the 5th IPCC assessment report gave very strong support to the Paris Agreement, for example. So let's move on the first part of my talk. What's the observed facts? So the first picture I want to show is the left panel, which is the change in the surface temperature over the past 2,000 years. You may know that the human has the significant entrustment measurements after the year of 1880. But before that, we have some the so-called proxy data to help us to understand what the climate change before the entrustment measurement. So you can, from the left panel, the temperature observed right now is quite significant warming, very high compared to the change in the 2000 years. You may know that from the pre-industrial era, the surface temperature has increased by 1.1 degrees centigrade. This is the latest observation of the temperature. And I mentioned the proxy data. Actually, we have many kinds of proxy data. For example, the sediments, the ocean sediment or lake sediment. This is very important proxy data we can apply, which we can apply in understand reconstruct the paleoclimate change. Another Loises, which is another important proxy data, which covers the past several millions of years, especially in China, in the western part of China, and ice core, which is very, very important proxy data. Ice core contain an abundance of the climate information, include the temperature and the carbon dioxide and methane concentration in the Earth in the paleoclimate age. For example, the Antarctic ice sheet now dates back more than 300,000 years. Ice core from the Greenland dates back to 120,000 years. And mountain glaciers, for example, the ice core observed in the Tibetan Plateau date back 10,000 years. So we do have more proxy data. For example, the tree ring, it's very useful for us to understand the climate, the paleoclimate, and also some historical documents. For example, the pens also is a kind of proxy data. So under this analysis of the paleoclimate data set and the current, right now we have the entrustmental measurement observation is a very more exact than the paleoclimate, but we can combine all these two different kind of climate data set to help us know what's the level, the warm level for us to live. This is the table since 1880, the global surface temperature ranking among the top 10 warmest year. The number one is the warmest year. See the year of 2016, and followed by 2020, last year, and 2019, 15, 17, 18, 14, 10, 2005, and the last one is 2013. So from this table, you can find that we are living in a world of significant and fast warming world. So this is the observation we have to understand how warm we are living. The temperature has increased by 0.08 degrees centigrade every 10 years. But after the year of 1981, the temperature has increased by 0.18 degrees centigrade. So the climate warming is accelerating. This is very significant. So let's move on to the reason of climate change. So usually we can clarify the reasons, the possible reason of climate change into two categories, two kinds. One is the natural causes, including solar radiation or volcano eruption and orbit parameters. Another kind is we call it anthropogenic reasons, include the emission of greenhouse gases, the emission of air pollutants, and also the urbanization and land use, something like that. So the climate change induced by anthropogenic reasons belongs to the definition of the political climate change, right? We usually use the theory of greenhouse effect to explain, to understand the reason of climate change, the climate warming. The Earth system observe the incoming solar radiation, and after the surface warm up, the outgoing long-wave radiation to the out of the Earth system. So the greenhouse gases are pretty important to keep the Earth warm. Although the carbon dioxide accounts for only a very, very little amount of the atmosphere, but it's important to warm the surface of the Earth system. For example, if there is no greenhouse effect, the average temperature of the Earth's surface is minus 18 degrees centigrade. Right now the average temperature worldwide is about 15 degrees centigrade. So the difference is 31 degrees centigrade is from the greenhouse effect induced by greenhouse gases, include carbon dioxide, methane, N2O, and other, for example, the HFC, PFC, and SF6, something like that. This is called a well-mixed long-wave greenhouse gases. You can, from the table in the rightmost column is the lifetime. Different greenhouse gases have different lifetime. For example, the carbon dioxide, in case it emitted to the atmosphere, usually it can be, the lifetime is longer than 50 to 200 years. So this is the reason in the international climate change negotiation, we know that is the common responsibility, but different response. This is a very important principle in the international climate change negotiation. Is the CD common CRDP, right? Okay. CPDR, okay. Yeah, thank you. So this is the longer time scale of the greenhouse gases. Is the scientific basis for that important principle of the climate change negotiation. So we can use climate system model. This is one of the important research tools, a kind of research approach, methodology for us to use in the to understand the reason of climate change. We also use a climate system model to make the future climate change projection. So what is climate system model? Actually, it refers to the mathematical physical model, which is based on the scientific understanding of dynamic, physical, chemical, and biological processes, and is used for quantitatively describing the state of each component of the complex climate system. Because that set of equations, which is used to describe the mechanism of the climate system, cannot be resolved mathematically. So we have turned to the go to the computer. So using the numerical method for solving the equations, the climate system model simulates and predicts the nonlinear complex behavior and process of the climate system through high performance computing. You may or may not know that actually the climate system modeling is used to be one of the users of the high performance computer facilities. We can use this climate model to carry out a kind of significant numerical experiments, help us to understand the reason of the climate change and how much contribution from the natural reasons and how much contribution induced by the anthropogenic reasons. So this is, I want to show this figure once again. This time, please see that the right panel. Actually, this you can find two curves with different colors. The above curve is the simulated by the climate system model induced, forced by the natural and human forcings. See that in this numerical experiment, we applied both the change in the solar radiation and also use the emission of carbon dioxide and other greenhouse gases to force the climate system model. So the model outputs give us the simulated surface average temperature. So from the right panel, you can find that the black curve is the observation of the surface temperature. And it's very similar with the model outputs, almost the same with the numerical experiments induced by the numerical climate system model. But the lower curve is the model outputs, which the model only forced by the natural forcings. So in that case, you can find the surface temperature is quite different from the observation. So this experiment tell us that the reason of the observed surface temperature change is most likely be induced by both the natural and anthropogenic forcings. But if we only think about the contribution from the natural forcings, see the change in the solar activity. That is likely not be the reason of observed change in the surface temperature. Okay, that is the way how we can definitely to distinguish between the reason from the natural factors and anthropogenic factors which contribute to climate change. And this is the latest results from the IPCC Working Pro 1 AR6. You can find this is the observed change in surface temperature. See 1.1 degree increase compared to the pre-industrial era, 1.1 degree. So this is the produced by the climate system model, almost the same with the observation. And the second column is the temperature rise induced not only by the carbon dioxide, see that 1.5 degree. This reports, this numerical experiment tell us that the carbon dioxide is the most important factors to warm the climate. But there are other anthropogenic, for example, the emission of the air pollutants, the aerosol, which has the effect of cooling. We call it umbrella effect. In case the most of the air pollutants emitted to the atmosphere, it will reflect more solar radiation back to the outspace, which can cool the Earth's climate. So the carbon dioxide warmed the climate by 1.5 and offset by the cooling effect of aerosol. So the residue is 1.1 degrees centigrade, very similar to the observation. So this is the, we call it numerical experiments of the attribution experiments, which can help us to understand the reason why the climate warm. The next slide I want to show you is that the very important scientific conclusion made by different IPCC assessment reports in the reason of climate change. You can find that back to the year of 1990, when IPCC launched its first assessment report, it believes that emission produced by human activities is increasing the concentration of greenhouse gases in the atmosphere, where we stretch surface effect and increase the temperature of the Earth's system. 5 years later, IPCC states that in its second assessment report, the current global warming is not likely entirely caused by nature, by the change in the solar radiation. Human activity has caused impact that can be distinguished towards global climate system. In 2001, IPCC's third assessment report emphasized that most of the observed warming in the past 50 years is possibly caused by the concentration of greenhouse gases increase attributes to human activities. In that time, IPCC gave the estimation of the probability, see the over 66% possibilities. The next, the IPCC Force Assessment Report in 2007 clearly indicates that global warming is an indisputable fact, and climate change in nearly half country is likely caused by human activities. So at that time, IPCC's assessment estimation about the possibility of this conclusion is over 90%. Next, in fifth IPCC assessment report conclude more than half of the global average Earth surface temperature increase from 1951 to 2010 is caused by the increased concentration of greenhouse gases caused by man-made emission and other human forces. The estimation of the possibility is over 95%. And finally, the latest IPCC report, which launched in this August, indicates that it is unequivocal that human influence has induced the widespread and rapid changes in atmosphere, ocean, and land. The reason why I took several minutes to read sentence by sentence the IPCC's conclusion within the attribution of climate change is the reason why is that I want to let you know that this is a very solid scientific basis for us to take the actions to significantly, deeply reduce the emission of carbon dioxide and other greenhouse gases, and also to take the climate neutrality actions. Now, let's move to the climate change projection. See how will the climate change in the future, and also how much emission space left for us. This is a very, very important figure made by IPCC, the latest assessment report. You can find that this is a linear relationship between the cumulative amount of carbon dioxide emitted by human beings and the temperature of growing the surface temperature. So this relation is quite linear. See, this is the emission of the accumulative emission accumulated after the industrial era till now. And this is the temperature rise. So the relation is quite linear. And from the right part of this figure is the projection, the future climate change. In this figure, you can find different colors. Say SLP 1, 1.9, SLP 1, 2.6, and this is the SLP 5, 8.5. You don't need to understand what's the exactly scientific meanings. The only you may understand only the meaning of this. We call it RCP. It's the representative concentration pathway. We define the different scenarios of future possible greenhouse gases emission in the 21st century, till the end of the century. RCP, or 1.9, this is the low emission. If the international community goes to the green and low carbon development pathway, the future emission of greenhouse gases will be relatively low. So this is RCP 1.9, and 2006, 4.5, and 0.6, and 6.0, something like 7, yes, 7.8, and yeah. So you don't need to understand the exactly meaning of this RCP. You can understand this is the different level of future emission greenhouse gases emission kind of scenarios. It's a kind of a set of assumption. So this is the green and lower and the low carbon developed pathway, and this is the high carbon developed pathway. So you can imagine that if the international community takes the pathway of the green and something like the carbon neutrality, so the future emission of greenhouse gases should be very in the lower level. So the temperature rise were very limited. But if we continue to develop in the high carbon pathway, see the RCP 8.5, so the temperature will increase very, very high. The temperature rise were very significant. See, RCP is a representative concentration pathway. It's a set of different scenario assumptions of the future greenhouse gases emission. So you can understand this is what is the RCP. And from the figure, you can find that another, we call the SSP. It is 1, 2, 3, 4, 5. What's the meaning of SSP? It is a shared social economic pathway. So SSP1 is the green and the lower emission of carbon dioxide. And so SSP1 is the future world we hope it occurred. And SSP5 is the very bad. It's a high carbon development pathway. So if you find some curves in that figure indicated by RCP, SSP5, 8.5, this is the high emission. SSP 5, 8.5. This is the bad, the worst emissions. We don't like that. So you can find SSP 1.9. This is the green scenarios. We like to have that scenarios in the near future, to the end of the century. So you can find from the figure that this is almost a linear relationship between the accumulative emission of greenhouse gases and the annual mean surface temperature. So this is a very important conclusion, the linear relationship. So the effect of greenhouse gases, the effect of greenhouse effect of carbon dioxide not only have the 1 year, the 1 year emission is also very important, but the most important for the greenhouse effect is within the accumulative emissions worldwide. So this is another solid scientific basis for climate change policies. So I guess you understand what the meaning of SSP 1.9. This is the lower emission scenarios. And The high-risk emission is the SSP 8.5. Okay, so right now we can apply the climate system model to generate the possible change in surface temperature till the end of this century, the change in the precipitation, the change in water resources, the change in the sea ice extent, snow cover, and other different components of the climate system. So this is the projection of the future climate change, the temperature rise. So you can find from the left panel, leftmost, this is the projection of SSP 1.9. This is the lower emission scenarios. So in this case, we expect the temperature rise at the at the end of this century, the temperature will increase by 1.5 degrees. This is where fit the requirement of the Paris Agreement. So this is the future we like. But the rightmost panel is the projection of surface temperature increase in the high emission scenarios. So in that case, the surface temperature may rise by higher than 4 degrees centigrade, very, very high compared to the pre-industrial era. So this is the scenarios we don't like to have that. Yes, so till now we can apply the climate system model to generate, to produce the projections of different scenarios. From this table, you can find that in the near future, the surface temperature will likely to increase by some degree centigrade. And in the middle of the century, and the rightmost column is the projection of the surface temperature rise at the end of this century. So in this case, the future, the climate change is determined by mankind. See, if we transfer our emission, for example, the economic system, the social economic system to a green and low carbon development pathway, so the surface temperature rise till the end of century we're likely to relatively low. But in other case, if we develop in the rely on the high carbon, we will emit more carbon dioxide and other greenhouses. So the surface temperature will likely to increase very, very significant at the end of the century. So the next slide is the carbon emission space left. See the carbon budget. You can find this table, how much the space we have. This is the historical cumulative carbon dioxide emission from the pre-industrial era to the year of 2019. See about 2,400 gigatons. This is the historical cumulative emissions of carbon dioxide. So from this slide is if we want to limit the surface temperature rise below 1.5 degrees centigrade, so we have to reduce significant by a large extent the emission of greenhouse gases. And this is the emission space left under different uncertainties. For example, if we want to keep temperature rise limit lower than 1.5 degree. This is the temperature limit target in Paris Agreement. We have only 500 gigaton carbon dioxide emission space left. This is the 50% likelihood. So you can find a different, for example, 2 degree centigrade temperature control target. In the 50% likelihood, we have 13 and 50 gigatons carbon dioxide emission space left for us, for the international community. So this table is the latest scientific achievement by the IPCC, the 6th sub-report, which can provide a very solid basis for the COP26 will be held the day after tomorrow. Okay, next, several slides I want to show you is the climate impact. Just very quick. This is a very comprehensive conclusion, the assessment conclusion made by the IPCC Working Group 2, the second working group of IPCC, emphasize the assessment in the field of climate change impact, adaptation, and vulnerability. This is quite comprehensive. You can find in the background it's a world map. If you find a symbol, for example, a fish, in some place, it indicates that the ocean system has already been changed significant. In this way, the fish and forestry and the water drop, something like that. This is the comprehensive assessment of climate change impact. And more information message you can receive from this panel, from the if you find the symbol with a four symbol, means this kind of significant change observed is due to the climate change, so the temperature rise or precipitation change. But if you find a symbol with the weird frame symbol, which means that this significant phenomenon caused by non-climate change factors. For example, the human activities, because, for example, we use more and more water. So in some places, some regions worldwide, the water resources has already been observed decrease dramatically, but this is now the reason from the change in precipitation, but from the more and more usage of water by the human system. So this is very comprehensive. But what's in the future? We can assess the possible change in the future climate change through different sectors, different regions, according to this definition, the risk of climate change conclude that we have to assess or consider the future risk of the climate change. We have to consider the hazard, which the future change in surface temperature and extreme weather and climate events. But we also have to think about the vulnerability of the human system and the natural system. And finally, the third factor is the exposure. We used to use the population or the GDP as an indicator to calculate the so-called exposure. So in the future, before the end of this century, we will have observed more and more significant impact, the negative impact of future climate change in different sectors, different regions. This is the important conclusion from Working Group 2 of IPCC, so-called 5 reasons of concern. You can find that different risks in this figure. Usually IPCC group the future risk into 5 categories. Say that unique and threatened system, extreme weather conditions, distributed impacts, global aggregate impact, and finally, the last one is the large-scale significant impact. And you can find if the color is very deep red, which indicates the higher risk in the near future for this system, for this sector or this region. So this is the scientific basis for us to determine the 2 degree or 1 degree centigrade as the temperature control target. So this is the scientific basis for the Paris Agreement. Actually, this is the last slide. This is made by my research group in the estimation of the future risk of high temperature, flood, and droughts in China. And you can find the red, the regions with red color means a higher risk in China to have with the challenge made by the high temperature heat wave, droughts, and strong or high precipitation. This is the risk, a case example of the risk in China. Okay, I want to finish my talk, and this is some message I want to let you take home message. It is unequivocal that human influence has induced the widespread and rapid changes in atmosphere, ocean, and land. Global surface temperature will continue to increase until at least the mid-century under all emissions scenarios considered, under different emission scenarios considered. See the lower emission SSP 1.9 to the high emission scenarios, see SSP 8.5. And global warming of 1.5 and 2 degrees centigrade, which is the limit, the temperature increase limit made by Paris Agreement, will be exceeded during the 21st century unless deep reduction in carbon dioxide and other greenhouse gas emissions occurred in the coming decades. And climate change has become a realistic and urgent crisis and a severe and long-term challenge for us, for all the human beings worldwide. And finally, in order to realize the sustainable development of human economy and society, our generation must take bolder actions for green transformation, and carbon neutrality is no longer an option, but a necessary action we have to take. Okay, that's the end of my talk. Thank you for your attention. Okay.